Summarize our equations up to this point. Don't forget our average velocity equation. It's change in position, your displacement over the change in time. You could also write this now as x minus x0 over the time. So it's my final x, my initial x, so that's the change in x. And assuming we start at t equals 0, you can just put over t. And we have another equation for average velocity. It is our initial velocity plus our final over 2. And that's for constant acceleration only, but so are our other equations that we derive from the graph, and that's what this unit is about. So we're okay using it. Just remember, this only works for constant acceleration. Then we developed some equations from our graphs. Our position was our initial position where we started, plus how far we go if we have a velocity at time t, plus how much extra distance we'll go if we're accelerating, or how much less we'll go if we're slowing down, negative acceleration. Then we have our velocity equation, which is our initial velocity, plus any extra velocity we get from accelerating or any we lose from negative acceleration. And the other acceleration equation, a equals a, we don't really need to use that. It's just telling us the acceleration is constant. Now the book will also come up with a whole bunch of other equations. And you might think more equations is great. No, more equations doesn't necessarily make things easier. Every problem in this unit can be solved with the equations you now see on the screen. There is one other one that I will use in class periodically, and it's not too bad, so let's take a look at it. And so let's take our average velocity equation and solve that for change in position. So x minus x0 is the average velocity times the time. Now average velocity is also v v0 plus v over 2. So I'm going to put that into there, and then I'm going to take my velocity equation and solve that for time. And so that is v minus v0 over the acceleration. My time is the change of velocity over the acceleration. And so I'm going to put that into here. And that's all the book does to come up with all the equations you'll see, is they just combine these equations. And so it's really not a new equation. But this one comes in handy. And so that's the average velocity. Substitute that into there. And then times the time, which is v minus v0 over a. And so we need to carry out this multiplication. And so I have v times a v0. And then I have a v0 times a v0. Times a negative 1, so you get negative v0 squared. And then I have a v times a v. I'm just carrying out this multiplication here. And then I have a v times a negative v0. And then this whole thing is over 2 times a. So if you don't follow what I just did, you need to practice your algebra. And so see if you can go from here to here. Maybe you do it slightly different, but you should get the same result. We can see some simplification here. I have a plus vv0 and a negative vv0. Those are gone. And I can pretty this up a little bit, and I get v squared minus v0 squared equals 2a times a change in position. And notice time is not in this equation, although it shows up in 3 out of the other 4. And so this one's useful if they don't give you time and don't ask for time. And so try that out in some of the homework. But again, you can solve any problem without using this equation.